We're two over there. We'll see, man. Maybe I'll take over.
I've never spent any time. So you joined the team there? No, I yeah. That is, I yeah, exactly. And I'm like,
you have some idea what you want to make? Yeah. I really. Yeah, definitely. Nah, I mean, I thought I'm just, I don't know, like, I don't have any idea. I want to see that what I get from it, and just enjoying the, you know, somebody has some cool idea and maybe interesting. Because I think it depends, right? Like, depends on like the tech stack with the like teammates has and everything. Even though that like I want to do one thing, but if I don't meet anybody else that has the same kind of skill set or talent that I need, then it's kind of hard to do it. Especially one day, right? Yeah. They said that they started 12. I don't know when we're gonna start back.
Unless you start doing it before.
Thank you.
Yeah.
Is there a charger for it?
It's a really nice song.
Okay. Is this your phone?
Yeah. It's
Oh,
what's my second?
Like somebody who 5 minutes, like you had to sweep out of yeah, this size is so many people that try to but it makes sense. I mean, what were you doing? Like,
I was also going to mention,
student, so I just
so we see the open source teaching in mid-June. That's where it's like bureaucrats and there's the founders. Everyone's a genius. And then we do build a company and a weekend launch a market. Whoever makes things well. That's my as well. And so if you're interested in coding,
I think the right thing
Oh yeah, I would love to help.
what about being like
Oh yeah, of course. Like I honestly like really love this experience. So like context, like organizing events this year, we did this year. Like, got like $500,000 budget, like had like a bunch of people.
how need like
And so like this one, that's how I got connected with my team. I honestly really love this.
Okay.
Okay. Wait, yeah. We can like follow up and like also have like a meeting sometime like after too. Wait, this is great. Yeah.
So my memory was like I built an AI agent in your workflow. So I get here. I mean, the reasons like how I sell it was if you hire me, like if you buy our software, you can fire someone, or at least you save half of your like every day. Like that was the idea, and then it kind of would work, and like people start paying you to build a product, and then you're able to build something, and then like sell people here. I get here was like, because this is a what first one was you build an AI agent to do research for case of pretty good. At the moment, like right now, I'm doing research. So that. No, I because I wasn't here based here for a while. I studied
Also,
here
earlier, what was your name?
but I went to end up doing so I built a turns out that
Like a sound.
No, yeah, just
I switched to something else. Customer side so I that's the the what do you do with your
Like it's always like.
so exciting. Yeah. I was only curious because I
sounds great. Wait, are you like left or
Do you mind or just for people outside about the space in general?
So I think like the Olympic space is really big. And I think it's like you can really build I think $1 billion applications just in terms of coding. You don't really need to like go. I mean, there's this illusion that people have that you have to have like deep tech and stuff. But if you actually execute well on whatever is existing, even if you use tech, but you have all these great platforms like Cursor or Perplexity and stuff. If you execute well, you can really get really far. And I guess part of the motivation is to tell people like how one thing is better than integrate out and give like some insights into like what happens in post-training and stuff. Yeah. I mean, I'm bound by a lot of confidentiality stuff, but I try my best to be as transparent as possible.
You work with a lot of other like labs. It's like confidential. And then so at Google like it seems like focused on presentations and like scope within that.
Yes, so basically I know your contribution to BS. I mean, overall, I focus on AI presentation, but within that I contribute to Learning, Project Astro, and Gemini to new models. And do RL, multimodal RL. And then, so specifically in the case, like right now I'm leading project transfer for like the past 2 quarters, and we like released it. Yeah.
Something that was, I think
Yes.
no, it was really cool. I'm curious how you think about like improving. Like at least for us, we spent some time looking at like content creators. One thing that we're looking at is like, I'm still a big guy, you know, it's like visually showing visually saying things, right? And like elements are very good at just text only, but there's still a really long way to go to like so I'm curious to like have like similar.
That is something, you know, that is one of the themes that is most recently trending right now, and that is part of my multi-modal where I actually work on improving like diagram generation and exactly like for learning. That actually we have this whole thing that we call realistic RL. We can define and we try to hire on different spaces, so like not only just the images but also on the reasoning and everything. So like previously people have done just on one aspect of the problems, like STEM problems. Now we try to actually ask the models, you know, do the entire steps, like just as you want to write everything, like draw the diagram, give you the steps, draw the final diagram, the intermediate diagrams based on the steps that are conditioned, initial as well as the steps, and then you use that with the feedback that
We've done like similar like stuff. We've worked on both like audio and image input.
okay,
Nice. We also done stuff like stuff, especially with everything like that. It's like really something
that's the, you know, like the models now, there is like some, I mean, I don't know if it's public, but I think it is. OpenAI models, I mean, OpenAI also released a blog post recently of like models using images to train up on their thoughts. I think that is something that people have started really getting excited about because people are seeing that there is a lot of benefit. I mean, I think just it just makes it easier for the models to not just write code or just just makes it easier for models to like understand what they're actually doing realistically when they try to do this kind of process. I think it's a pretty exciting space.
If you guys can hack this shit, that day, you're gonna lose $1 million. So, one thing that I heard was like, you know that if you want to execute the problem, like you have to go through so many security. Sometimes that they kind of push the
I think it's a great question. So, one of the observations that text is getting saturated, and the amount of information you have in that is like kind of limited. Now we're starting with videos, because they are more richer signals. You have like a lot of things like physics and videos. You have like this native audio, like you have this native multimodal behavior, just like image process information and stuff. You've started looking at that, but I would say like a lot of this is like early work. People haven't found like the right recipe to extract like, the maximal information that is possible from this kind of sources. But I think the models are getting it. Like, slowly, eventually, you will kind of have this rapid
super exciting space. Like we're also super positive about maybe like making AI work something how do we use it to
Okay. Right. This is a good time to start because you're like ahead of the pack already. Because agents are just getting started. Like they just don't have I mean, you can make that much. And if you start developing really killer use cases and really solving, I think one thing, one oversight that a lot of these big tech companies have is in actually solving for that end user experience. Like for a lot of these new niche use cases, they don't focus as closely as possible on the end user, like the students in your case. And if you can find things that make, they can be simple engineering things. If you can find those wow moments, those simple connections here and there that actually make this experience more seamless, something more natural, as natural as possible, I think you can really get like a great user base.
No, we completely agree. Like our company, so we provide data, but we basically provide it for like very narrow use cases, and like the reason why we switching to us versus like other vendors is because we actually like did the work most actually useful. Like we actually applied it at like the exact data that we think is useful. So for example, like the contact that we usually have us like like asking how they learn that. And like will take my conclusions much better than someone, right? So yeah, I completely agree on that. Like there's a lot of value for everyone to actually understand, like really understand the
And I'm so glad that you guys are doing the right, you're solving it from the right angle, because a lot of people are trying to put old tech without even thinking about like what the users need it or not, right? So you don't want to do that. Like you just don't want to like automate something that a user doesn't like uses in 1 million things. You really want to see what are the main pain points that the users have in their learning journeys. What is something? This comes a lot through participatory research, talking to people, connecting them. That sharing those insights with tech is also a niche space. I think that's also something that is very valuable in general. I think that's also a lot of potential there. Telling them that hey, these are the problems, and this is the kind of targeted data we have for this kind of problem. People will just be willing to throw money and find.
No, we definitely love to like set up a time with like you or someone on your team to talk about like what we worked on in this space.
For sure, we'd love to. I mean, we also partner with a lot of companies. We have like this program to which we currently have partnered with like ESG. Right. We also partnered with Go and others. So we have a lot of partners, and we love people to come and partner with us because I think this is something that not one company can solve. It's something that has to be a collective effort. A lot of these societal impact efforts, right? They are supposed to be like collective things because if you kind of make this like, I mean, if you like consolidate all this into like one company, then you'll obviously run into a lot of these biases. Like the directionality of that is not going to be the right.
Yeah, we'd love to talk to you next week.
Yeah, for sure. Yeah, feel free to set up some time. Yeah, for sure. You can. You can come over to Google and we can meet there. And you can also meet. I'm in the Gradient Canopy office, which is where most of the
That'd be awesome. Yeah, I was working last night. I dropped it off during my first semester, I was doing and also interviewing.
Oh, nice.
So I don't always go to
Bayview?
Yeah, Bayview and just like the original campus.
Oh yeah, the B40.
Yeah. But no, we'd love to come in person.
Awesome. We'll be happy to host you guys. And I'll also try to get in some of the other folks. So there's this whole right now it's a very good time actually because we have this whole effort in GDM where education has become the core. like a full website, and we are sourcing a lot of data from a lot of vendors. If you guys have something, that we would love to purchase that.
Is there like that data that works best or like?
Yeah, let's discuss this later. Yeah, let's discuss this.
We're just like really happy.
I would say it's a difficult partner sometimes to work with. And they leave to some place. They can't share a lot of information. They don't want to be There's a lot of data bias. What is our work responsibility? It's not also, it's not something that's not settled that can be validated. We also find that some users don't play a lot of and we have this whole problem where we have to throw out every chunk of data because it's not aligning with multiple data that everyone is using all different yeah, so like we have set up, so we're working on the business like some person that then people from our company work with us and we kind of give instructions and then they take it up and what they do is they actually write more million instructions and then they send it to the that's all. Yeah, for sure.
Good morning, everyone. The opening ceremony will start at 11:10 a.m., so please congregate in this main area. Thank you.
Nope. So silly. Excuse me. Sorry.
Yeah, I'm not. So my backup is
Dude, down to your side. It's too many people. Well, I mean, like I'm going to hear you. Yeah, I don't know too much about it. I know it's fine. Yeah. Professor missed like he like somehow makes something as interesting as that man. Like it's so I just haven't I'm cooked. It's like a have you ever used like bodice? Because that's what we do. It's like a software. It's not really layers. It's like a like that. Wait, so with parallel, like, what do you do? Yeah, that's a much better job. I'm telling you. I'm telling you.
Do you focus on
I'm doing the full. I'm full stack. I do both, and then but lately I was just spending much time on the building the AI games. So pretty much like I do everything.
I think second process is that we're going to be
Yeah, future I think so. I think you need to probably in the future they're like who understand like what the software has to do. Well, how it looks like, right? Because right now you can like right now I'm kind of doing like working with the startups, kind of like try out, and ideally write a code. Like, I barely touch the code. I always do telling the cursor or anything else to like, hey, do this, do that. I'm just more seeing from like higher level, like, okay, so exactly, architecture, because it's getting better. You know, like yesterday, the Sonnet 4 was come out, right?
Yeah.
It's like a lot better.
Yeah,
But still, when you come into like architecture or like you need to know what AI said makes sense to you. Because the thing here is there's no answer to the reality. Let's say you have a database, right? And then you want to do something with database, but it depends on where's the user, right? If the user in the like San Francisco, only one place versus like all around the world, right? What is your service? Like there's all the trade-off. And I think AI is really good with that, but still, as a human, you need to make the call. But how are you going to make the call if you have no idea? Right? Yeah. Or like solution architecture.
So there are so many applications that are building
I mean, it's already going there. Like, I tried a Lovable first time like 2 weeks ago. Then I was just shocked. Like, it does everything. Like front end, obviously, has a lot of issues. But it builds up front end, it connects with the back end, server base, and then they were able to do the basic functionality. So I was very impressed. It's crazy.
Yeah, just do several things.
Good.
I feel like the coding part is human part. I mean, like environment, because all the people
Yeah.
of course, like
Yeah, human is the slowest part. Human is the slowest part. Human is the bottleneck. You gotta remove human. Yeah. I agree.
Welcome to Agenthacks! It is a glorious day to bring some small fraction of the future of AGI to the world with you today. And in your hands is the capacity to build something and ship something great. Welcome to AGI House, where we love inviting young creative minds to burst their dreams into existence and ship them. So my name is Jeremy, I'm the founder of AGI House, and I can't wait to code and hack with you all tonight. We're gonna open it up with one of the central minds behind Agenthacks, Christina Young. Let's hear it for Christina. Who will run us through exactly what we'll be building here today and through our fantastic sponsors. Christina, take it away.
Thank you, Jeremy. Hi, how is everyone doing today? That was very dry. Come on now. How is everyone doing today? Sorry, y'all. Okay. Oh, that's not bad. Okay. So here's the quick schedule. We'll intro, sponsors, keynote speaker, and logistics. So this is a 2-day hackathon. We have 500 plus registries from all over the world, including Stanford, Berkeley, Waterloo, NYU, MIT, CMU, Georgia Tech, Princeton, UPenn, Harvard, and many more. I've met some people who flew in for the hackathon and other events, so thank you so much for coming. And so what is Agenthacks? It's hosted by AfterQuery, Dex, and AGI House, and it's bridging the gap between academic research and real-world AI applications. We're building, learning, and collaborating with top-tier researchers and mentors. And so here are our hosts. We have AfterQuery. Give us a hand for AfterQuery. This is Spencer.
Yeah, so happy to give a quick background on AfterQuery. We're a research lab that investigates shortcomings in different types of AI models, so both LLMs as well as computer use models or agentic models, very similar to the focus of the hackathon. And then we provide data to the leading AI companies who make these models to improve in the shortcomings we identify. We're based in SF, and if you're looking for any part-time contract roles, we hire a bunch of software engineers to help us with the data collection for our research. And yeah, you can check it out at our site here.
And now we have our other co-host, Dex. And this is Regina.
Hey guys, so we're an applied research and product company, and we're working on building the next interface for work or for human AI collaboration on the browser. Some problems that we're solving. So we believe that the browser today is not really built for an AI native world. You constantly have to context switch, like tabs should not exist the way that they do right now, and everyone is mentally overloaded. And a lot of agents today are still kind of like in these siloed platforms and chat interfaces, and we kind of want to move away from that. And then additionally, if you think about how you work day to day, all of your applications don't really remember anything about you or your workflows. And that's something that we want to kind of fix. So what we do is we're kind of a personalized action layer that sits on top of the browser. It turns your intent or your thoughts directly into actions as fast as possible. So we're kind of bridging this and creating less friction in between. And then we're also hiring right now, so we're looking for engineers, product designers, and researchers to work on interesting problems in personalization, memory, and evals. So here are some open roles. You can go to joindex.com to see our product today, and then for the research roles, it's on thirdlayer.inc.
Thank you so much, Regina. And now we have the AGI House with Jeremy.
Thank you. So at the core of AGI House is actually the question of the trajectory of our civilization and what it looks like to be moving into an intelligence age where fundamentally the way in which we think collectively will be transformed by a novel technology. In that case, machine learning and large language models have done a ton, but are the infancy of the kind of impact that I'd expect them to have. And so as someone who's really deeply invested, so for context, I was at Google Brain 2017, 2018, 2019, when we invented the transformer. Most of my work is on uncertainty estimation and meta learning, but I wanted to create a meta community where people could basically build on the raw and sort of very your early stage projects that turn into fantastic research and product applications. And so myself and my roommates decided to basically co-rent mansions and have massive hackathons in them on a continuous basis so that we could catalyze what we saw as the raw material of the startup ecosystem and the research ecosystem, where people would just casually meet people as friends instead of having it be combative or having them sort of have some corporate allegiance that made it impossible for them to work together, and hack on the kinds of side project and early ideas that turned into great companies. So for example, the original AGI House in Hillsborough with Audrey Karpathy and myself and our roommates featured Arvind Srinivas, who was at OpenAI casually hacking on this SQL search engine based on Twitter that turned into Perplexity. And so the path from hackathon project to $9+ billion company is actually shockingly short in our world. And that could be a search engine. It could be the new way that people access information. My roommate, Div Garg, is currently building the next generation of AI browser agents. All of these are things that get incubated as curiosities, as ideas that you could come up with today. And so the core idea behind AGI House is to create this really high-quality AI-centric meta-community that is on the bleeding edge of technological progress when it comes to creating an intelligence age that we all want to live through. So hopefully you can all be a part of that dream today. I believe in you.
Thank you so much, Jeremy. And now a word from our sponsors as well. So Trae is up first.
I'm excited, and also I see some old friend. Okay, guys. Thank you so much for joining our hackathon. And my name is Gary, and our product is called Trae. And let's see. Okay. Give me 1 sec. Okay. So how I can switch the slide over there? Seems like it's not working. Okay, perfect. Okay, it's okay. It's cool. It's a machine issue. Okay, so it's like the AI is not trying to replace the human. You will still get some chance to at least on the PPT. Okay, so first of all, as you can see, what is Trae? And I do believe a lot of people, we guys do AI coding, right? And you guys can know us. We are one of AI coding product from one of most famous company in the world. But I'm not going to say which company it is. You guys can do some research. And yeah, this is one hook. Another hook is like, what are we doing? We help developer to build faster and collaborate with AI easier. So this is why I wish you guys can have a try to use Trae to build it to see if it's really work. Okay, so we're really glad to announce we are the biggest competitor to Cursor in the world right now. We just launched our product for 3 months and we already break more than 1 million users in the whole world. And also, a lot of people, they say, hey, what AI coding can do for us? I just get some survey data. Maybe it's not true, but you guys can take a look. For some startup company, especially in the San Francisco, they say, hey, the AI coding can help them to boost their productivity maybe 2 times to 3 times, and also help the team save the cost around probably 50%. But if you have some remote worker, then it probably is another story. Okay. Another thing is like right now, people they will ask, hey, why Trae is growing so fast? And I would like to say another hook is we offer free service to all the people, including all these most cutting edge model, no matter it's like Cloud 3.5, Cloud 3.7, and also Cloud 4. And they just launched yesterday. You can just try this most powerful model in Trae for free. Yeah, you're correct. It's free. And also including Gemini 2.5 Pro, GPT 4.1, and also DeepSeek. Just try it out to see which one you will like it. And today, you can use Trae, use this most cutting edge model to program to build your product. Also, I think everyone can take a photo with this image because right now, if you follow this process, you basically can enjoy the unlimited LLM today. It's really easy to set up. Control-Shift+P and input open user setting, and then you just input this code. You will just use this powerful model to code today. Okay, I will just leave for 3-5 seconds, and later I can also share to everyone. No rush. Yeah, by the way, let me do one small survey. What is your favorite coding model so far? Anyone? Cloud or GPT? Cloud. Everyone see Cloud, right? Anyone try Cloud 4 or no? Yeah. 1, 2, 3, 4, 5. Not that much. You guys can try it out. Let me know what's the response. Let's see if it's really better than Gemini or GPT. Okay, also, we are currently building our ecosystem in the whole world right now with those, best school, and also the incubator. You can see we host a lot of hackathon and also different events, GitHub, SAT, Berkeley, Stanford, CMU, and also we have a lot of tight connection with AWS and also, plug and play So if anyone wants to create one company or looking for the VC investment, and can also looking forward to us. Also, in the left, this is my LinkedIn. In the right side is the WhatsApp group. If you got any question or you want to have more question to me, just let me know. So that's all. Enjoy hacking today. By the way, do I need to tell how people they join the hackathon or later? Okay.
Okay, thank you so much. And next up we have Dalus, and from Dalus we have Elliot, who is the CTO of Dalus.
Hello, everybody. So today I'm just going to talk about like how me and my co-founder got here, what we're building, and like where we're headed. So let's go through it. So we're building AI-powered systems engineering software for engineering teams building complex hardware. So think of systems like airplanes, rockets, satellites, robots, nuclear power plants, any large complex system that involves many disciplines, and a huge bottleneck to developing these systems is just communication. And that was my experience working at Aerojet Rocketdyne for a couple years as a systems integration and test engineer. The biggest bottleneck to making progress was, just collaborating, communicating with a cross-functional team. Everybody's an expert in something and doesn't know how to talk to other people, so I'm kind of like the mediator. And another way to like picture or describe this problem space is it's really a problem about access to accurate, up-to-date information. In the hardware world, we don't have the luxury of having a single source of truth, like a software repository that is perfectly version controlled, right? We have Microsoft Word docs and PowerPoints and Excel sheets, and everything's super messy, and it's really hard to enforce traceability from those requirements to verifying that you're actually meeting these requirements. And that's like super important for these mission critical systems. And my co-founder has done 2 startups in the past and also did a project with the European Space Agency to perform some modeling. And we discovered that the current software that these companies are using to model their system is super outdated and expensive, and it's causing a lot of problems. Like, it's kind of creating the silos that they're trying to prevent because it's so hard to learn how to use that very few people use it, and the other engineers end up passing documents around anyway to the people who use this software in order to model it. And so we're trying to build a more intuitive platform that serves as a single source of truth for the system that they're designing and trying to verify and ultimately build and test. So our platform includes like system modeling, which you can kind of just picture like as block diagrams and functions and functional descriptions. Requirement traceability and verification. You can assign requirements to different components, and it's in a real-time collaborative environment, and you can upload documentation and all the while have access to an AI co-pilot that knows your system inside and out. And here's a little pilot project we did with an enterprise, Israel Aerospace Industries. We basically built out some core AI capabilities that they were looking for to automatically generate these system architectures. And we've shown that we can reduce their manual work by up to 80%. And next we want to build enterprise-grade security and deploy that in our production setting. We can bring these capabilities to a real environment, and then build some more integrations with other tools in the hardware engineering tool stack, like product lifecycle management and CAD software. We're Dalus. We're building for the next generation of engineers, for the next generation of systems, which are getting more and more complex every year. I'm curious to see how you guys could explore different AI applications in this field, in this domain. Thanks.
Thank you so much, Elliot. Next up, we have Leaping AI. we'll skip this for now. Next up is Novita, and we have Junyu Huang, the COO of Novita. Everyone give him a round of applause.
Hey guys, nice to meet everyone. Good morning. Glad to be here. I'm Junyu. I'm from Novita. So at Novita, we're building AI cloud for everyone. So we're making open source AI accessible to everyone. Show of hands, who here has dealt with dealing with GPU and trying to host models and trying to figure out, what's the best way to have the most cost-effective way to host model and optimize for performance and all of that.
Enjoy hacking.
Great, so a lot of you guys. And for those, and good news, from now on, you can stop wasting time on all of those things. And for those of you who don't show your hands, also good news, because you don't have to ever. So just let us do the job for you guys. So stop wasting time on infrastructure and optimization, reliability, and cost, because we deliver affordable, high-performance inference out of the box. So we support more than 100 models, open source models with a simple API. We handle all of the optimization, hosting under the hood for you guys. You just call a simple API, and you'll be sure to have the most affordable, high performance, and reliable APIs for models including Llama 4, DeepSeek, Qwen 3, and all of the top models out there. And we also support deploying custom models. If you have your own fine-tuned models of your own, you can also do it on our infrastructure. We also have globally distributed GPUs if you ever need GPUs to do whatever you want as well. So a bit of where we are today. We started a bit more than a year ago, and right now we process well over 200 billion tokens per day for our customers. We support more than 100 models and growing every day. Right now we have more than 210,000 registered users on our platform. We're one of the very few providers to have guaranteed uptime for our APIs. We're very fortunate to be trusted by some of the leading AI startups and open source partners. So we are one of the official inference providers on Hugging Face. We work closely with VRM and SGN as well. So yeah, very excited to be working with a lot of companies out there. So if any of you who needs APIs or GPUs or want to talk about anything, just feel free to reach out to me on LinkedIn or official channels. Okay. Oops. Or you can just search me, my name on LinkedIn. You can find me. Or just come to me after this. And so, yeah, one more thing. We're very excited to be working with the host to make this event happen, and very excited to see what you guys built. So if you guys go to novita.ai/agenthacks, you'll get $25 in free ARM API credits, and you can build whatever you want with the API. It's free, no credit card required, just good vibes and free APIs. So, right. Thanks, guys.
Part of the last winter white sea batch. OCR agents are the hot topic part of the last winter white sea batch. OCR agents are the hot topic part of the last winter white sea batch. OCR agents are the hot topic.
I think it's because I have
actually.
House.
Yeah. I have.
You're playing a lot.
Sorry about that, y'all.
Hey everyone, my name is Kevin and I am the CEO of Leaping AI, part of the last winter YC batch. Voice AI agents are the hot topic of 2025. They can be used for anything from customer service to sales enablement to ops. In our Hackathon challenge, we invite you to deep dive into the world of voice AI agents by leveraging the beginner-friendly tools and APIs of Leaping AI, an innovative voice AI agent platform company based here in SA. Amaze the world by building a killer voice AI agent and win awesome prizes, such as a sponsored dinner here in SF with our team and one-on-one personalized coaching sessions for your next YC application. Scan the QR code on the next slide to learn more about our challenge. Happy hacking.
Thank you for Kevin. The QR code will be presented later, but next up we have our keynote speaker, Shubham Paul, from Google DeepMind. Everyone give him a round of applause.
No, I was actually about to do that.
Hey everyone, it's nice to see all of you here today. And today I'm going to talk about the advent of AI agents and transforming, particularly touching on some of their impact that they have had in the education space. But before that, a little bit about me. I'm a research engineer at Google DeepMind, and my core focus at DeepMind is on AI for education. This is a team that I helped start in, I would say, like 2023, and then from then on, I've gone on to contribute to a lot of projects that DeepMind has, which is one of them is LearnLM, one of them is Project Astra, which had a lot of representation at Google I/O a few days back. And more recently, I've joined Gemini. I've contributed to the Gemini 2.5 family of models, and I've been working on multimodal RL in this space for Gemini. At I/O this year, we also announced the project that I was the tech lead for, which was the Astra AI tutor. So today, I'm going to, initially, I find this space fascinating, like how we got here to the point where we have this great degree of autonomous agents. So I'm going to start with a little bit of the past and the leaps in technological progress we have made over the years to where we are now. And then I'm going to give you some behind the scenes insights of how Project Astra has been built, how we built the AI tutor, and stuff like that, and some tips and tricks to really be successful in this agentic era and win in the agentic era, right? So I think, not saying this is the most perfect timeline, but we already had AI agents back in 1950s. The only thing that differed was in terms of their capabilities, right? So at the most fundamental level, if you have to think what an agent does, is that it observes the environment, it does some processing, which is part of the thinking, and then it takes actions based on its observations. Now, what has happened over time is that these three individual aspects of the agent capabilities have evolved. The observation, in the past, if you had the earliest AI programs, I think was the logic theorists from Newell and Simon that they had developed that could solve mathematical proofs. Then you had Shaky the robot from Stanford, where this was one of the, the forefathers of all the autonomous driving cars and all the robotic embodied AI systems that we see today. But what did they miss, right? So some key components that were lacking in these AI systems of the past was that one of them was like language understanding, right? You couldn't really tell the model something like as you're doing right now and ask them to perform that task. Most of them were like hard-coded based on like a lot of rule-based logic systems, symbolic reasoning systems, and stuff like that, right? And then you had also a lack of contextual awareness. Most of their actions were limited to the immediate input that they consumed. And they were also very task specific. So for instance, the logic theorist was only specific to solving like mathematical proofs. And then you had other agents that were very, very specific to that task. So it wasn't an experience that we see today. But this changed. Over the course of, I guess, I would say like 50 years, we already had virtual assistants. And when virtual assistants came out, I think it started with Siri way back. One of the things that they did was that this interface between the humans and the AI, they greatly got simplified, right? So they demonstrated the first signs of natural language understanding, really trying to really understanding what the users were saying. And then they had these other components to it, like speech recognition generation, so they could actually talk back to you, they could understand what you're saying, and then based on their limited understanding on whatever logic systems that they were based on, they could then process this information in some form and integrate with like some external systems. For instance, like for now, you can have like Alexa connecting with devices at your home, and the other assistants do this as well, right? But again, here, they were missing some key components that you would need to build like a truly universal AI system, right? One of them was reasoning. So again, these agents never focused on like complex reasoning tasks. Rather, they had like again very simplified interfaces to interact. You could only say turn on your light in a certain number of ways. You couldn't give it a puzzle and ask it to turn on your light, for instance, right? So this is something that they lacked. They also lacked planning. Like they couldn't plan further ahead in time. They also had a very limited memory about the user and multimodality. And this is something like, by multimodality, I mean some like natively processing all the sources of modality together in one system. They kind of achieve this, sometimes via multiple systems like separate vision processing, separate language processing, and then combining that thing, right? And then we had this whole revolution, like the sequence-to-sequence architectures started coming into play, and people realized that the basic task that they wanted to achieve was that they wanted to give these models an input in some representation, which was a sequence, and they wanted to get from the models an output or the action, which is again another representation or an output sequence, right? So that's how the old seek-to-seek architecture paper then led to other innovations like transformers, and then we started moving on to people started scaling this up. They started realizing that if you actually throw a lot of data and compute at these systems, they start developing a more general understanding of the world. And that is how, we had like some early signs of this, like from GPT-3, and then we had like the big ChatGPT moment. But I think one of the things that is interesting to appreciate here is how fast these developments occurred. So from the time that the first virtual assistants came out, that was just 50 years after these initial rule-based systems, you had like within the next decade, you had models that could now truly understand what users were saying. You had models, and the early versions of these models, right, like GPT-3 and all, you couldn't really give them instructions and ask it to do the task for you. Instead, you had to like really few shot prompt it or like put a lot of chain of thought prompting and a lot of other things that had to be done in order to achieve the results that you desired from these models. But what you did see in these models was this evolving understanding and an evolving intelligence of the world, which was fascinating. And then I think with FLAN, there was this paradigm of instruction tuning that was introduced, where what they did was they decided that if you actually throw a lot of data, which is of the form of instructions as in the prompt, and the output containing a sequence of the model following that instruction, and if you just train the model on these two sequences, you can now actually get the models to start following instructions really well. And that's, I think, where we had this big chat GPT moment. I think it was released at a research conference like NeurIPS, if I'm not wrong, and nobody expected that it would blow up. But the reason why it blew up was that for the first time you had at your fingertips an intelligence that could truly understand what you're saying without you giving it examples of what it should do. You could ask it to perform a task and it would do that task for you. And then again with GPT-4 you had this other evolution of where you could now not only ask it, you could now not only provide it text instructions, you could also provide it multimodal data, like images and text, and it could process them jointly and produce the follow the same set of instructions, right? So what these language models led to, or what were the key capabilities of these models that were unlocked by the key capabilities that were unlocked by LLMs were advanced understanding across multiple modalities, this ability to natively process every single sort of modality without having separate models to do each of them and then trying to combine them in some form or the other. There was an ease of control which got a lot of which is why they became popular with people, and this was directly through natural language instructions. They have now an evolving sense of reasoning and planning. Models are learning to think, and they're thinking deep, they're thinking fast, and they have started reasoning and planning pretty well. Tool use and API integration was another use case that got unlocked because of LLMs. Because now what you could say is that you could provide an API interface for the model to use, and you could say that these are the APIs that I have, these are the context, this is the context under which I want you to use this API, and the model would figure out the rest, like how should I call this particular API, like if it's a search API, it would rewrite the query that you gave to make it a search query and then call the search API, do the searching for you, and so on and so forth, right? Long context. This is something that has been continuously increasing, as we've seen in the recent developments. You started with models having a context of about 1024 tokens. Then went on to, and now we have models that have about 10 million context and even more. And also there are papers that claim infinite context and whatnot, right? And some more interesting emerging properties of the recent LLMs is this behavior of self-reflection and correction that emerges through the process of training. So one thing that is interesting that happens when you start training these models and when you allow them to explore this space, especially in RL training regimes, is that they start, whenever you give them a reward for performing a task correctly or not, they start thinking longer and longer. So this is something that you notice. I think if you have read the DeepSeek papers as well, you see that the amount of thinking that the models do, as the complexity of tasks increases, the models also start thinking deeper. And part of this thinking process is also reflecting on their previous thoughts and correcting it, much like sometimes what humans do, right? And you have this other paradigm of retrieval augmented generation, which is opening up tremendous possibilities of having models that are completely online, that are not stale after they have been trained, and they can retrieve relevant context from the internet, use that to formulate their responses, and so on and so forth, right? Now, if I were to summarize, and this is a very vague summary of what are some of the characteristics that enable the LLM agentic era, and what are some noticeable patterns that you see here. So one thing that you have seen in the creation of a lot of these agents is that people are using LLMs as the central orchestrator in many cases, or the central decision maker. And that is inherently because you don't want to have a deterministic sense of deterministic logic, because that doesn't scale up as well. You don't want to have rules in the intermediate steps, because
every time you see some out of distribution query, you want some amount of generalization in the decision maker that is there. So that is why nowadays, with LLMs having improved reasoning, improved understanding, they have started to serve as this central orchestrator or decision makers. And what the orchestrator does is that it coordinates with series of specialized LLMs sometimes to perform a set of specialized tasks, and that is how a lot of like agentic applications are built. Another thing that people have also started doing is that they have started making, they know that one of the limitations of LLMs is that they are kind of restricted at the moment to perform like simple tasks. So what they do is that they break down like a really complex task into like a bunch of simple tasks, and then they chain all the LLMs together to create more and more complex automation workflows. And there's also a lot of interesting research that is going on right now in like multi-agent collaboration. I think this is a super exciting direction, because what it allows agents to do in this kind of setup is that you can have like a family of agents that are talking to each other, collaborating on some particular task, and you could have feedback that is coming from different agents, and your task execution then kind of entails this collaborative discussion that follows. What we are doing right now is we know that these LLMs are limited in their capabilities. So a lot of the cool AI agents that you have seen are kind of basically built by having like solid engineering infrastructure that is kind of designed to mask these implicit limitations that the LLMs have. And some of this is very simple to do. Like for instance, if you know that an LLM is bound to perform not perform very well at reasoning, things you can do is like you can query the LLM multiple times, sample it multiple times, then use like a majority vote from the sample rather than using a single sample, and you kind of design your engineering infra based on around the limitations. Like this is just one example, but there are many ways in which you can do this to mask the limitations, right? But again, one thing that is missing in the current LLM agentic era, that is still, I think, some things that we need to solve for is we do not fully trust the reasoning abilities of these LLMs, right? So you wouldn't ask it to be like your stock portfolio manager or something like that. You wouldn't want an LLM to automatically trade on your behalf. Even though you know that it's a very good reasoning agent, it can solve Olympiad level math problems. You know that sometimes when you twist the problem in certain ways, it can even get simple problems wrong. I think there's this, I don't know if you have read, but like there's this interesting paper that came out from Apple last year where there was a very easy data set, GSM-8K, which people thought was saturated. But what they just did was that they just changed the wording of problems there, and they just showed that all these LLMs now fail to solve the same problems when you just change the wording. But to a human, it made no difference. So we really don't know LLMs in depth. So we really can't probe their knowledge, and therefore there's a lack of trust and confidence in the reasoning abilities. We also haven't seen really long horizon planning. And this is kind of important because at the moment you have agents that are doing like one task, but have failed to like kind of generalize to perform like a whole range of tasks. Like you have like coding specialized agents, and a part of that is because they lack a little bit of this planning capabilities where and planning is kind of a precursor to a lot of the generalization work. They also don't have infinite memory and context. It's often limited, so the amount of like stuff that you can include inside the prompt is often limited. And latency and performance, they are kind of like again at odds with each other in the current setups. Now people have seen interesting results with like text diffusion and other architectures that are kind of like having showing some signs of getting both latency and performance good. I mean at par with each other, but at the moment with all the inference time compute research and stuff, it's kind of been shown that that you get better performance with if you take a hit on latency, and vice versa. So if you drop performance when you decrease, and if you decrease the performance, then you can have reduced latency. And again, they are not cost effective. So a lot of the decisions that the LLMs are taking in their thinking process, for instance, right now,
they are outputting like a whole bunch of garbage tokens that is absolutely not needed. And I think there are areas here that people can focus on and really like improve the capabilities of LLMs. They aren't matching the intelligence of a superhuman. I mean, they aren't at a superhuman level intelligence. Sometimes like these coding agents do like really weird. I don't know if you've seen this, but they would like list files repeatedly, although they have just done the same action like in the past to see the same directory, even though they have this the same context. Not something that a human would do. But again, like this is something that trajectories need to be optimized, and therefore that would kind of also tie down to the cost, right? But even though we have these limitations, we're seeing like really fascinating agents come out. We have Operator from OpenAI, we have Project Mariner from DeepMind. These are some browser-based agents, and again, like there were some browser-based agents that were discussed today, which are also great. And then you have coding agents like Claude, you have Cursor, and you have Jules and Codex. And these are really cool applications that people are really finding great utility in. So what can we learn from this? And I think part of this is important because if we were to make some bets, it's important to know what the trends are. So one thing that is consistent across the LLMs is that the intelligence is increasing by the day. So you can be assured that by next year, same time, you would have a much more intelligent agent, probably like 10x more intelligent than what it is now. You also are getting broader contextual understanding. You're getting more native multi-turn, multimodal interactions, which were not available in the past. They have started leveraging memory in some form. I think this is a feature that if you have seen, I think is in ChatGPT, is in Gemini, but you can see like they have this small concept of memory where they kind of at the moment is very fuzzy in terms of like how it's implemented and stuff. It's not the best way of implementing memory, and the one thing that is interesting is that there is this expanded action space where you now have this interfaces where it can interact with a whole range of tools, and it can also generalize to new tools. So all you have to do is tell the LLM what the tool is for, tell the LLM how to use it, and you don't even need to give it like few short examples anymore. The LLM just figures out how to like what the best way to use what the best context and the way to use the tool would be, right? And we're seeing that the autonomy of these agents is gradually increasing. So this is what is common with the coding agents. Like previously, they could fix like one bug. Now they can create an entire software engineering project. Like they can almost complete a project, right? And collaborative intelligence is also gaining some sort of popularity right now, where multiple agents are collaborating. And again, like this part of research is always debated because people say like if you can do something with multiple models, there's this notion that if you can do this with multiple models, you can also distill it into doing the same thing with just one model. So this is again debated, but I think it's going to be there and it's going to stay for a while until and unless we have like one agent that knows it all, and probably then that would be like AGI. But at the moment, collaborative intelligence, where you have specialized agents for tasks, seems like a viable good step. So now, based on whatever I discussed today, I'm going to introduce Project Astra to those who don't know about it. And this is a project that I work on. So Project Astra is Google DeepMind's bet into building a universal AI assistant. Or you could say it's our bet on achieving AGI, right? And one of the things that is unique to Project Astra is that it can natively, like it sees, it hears, it speaks, it remembers, it takes actions, and it does a bunch of stuff. So I'm going to play a video of our, just to give you a sense of what it exactly is. And this is an AI tutor that we explored with Project Astra recently.
Can you help me out with question number 39 here?
Of course. Is this the problem?
Yes, I don't really understand what to do here.
No problem. Let's take this to the blackboard. The key concept here is optical isomerism.
Got it. But how can I tell if an isomer is optically active?
Optically active compounds require a chiral carbon atom. A chiral carbon is one that is bonded to 4 different groups.
Okay, awesome. That makes sense. So how do I apply that to solve this problem?
Let me walk you through the steps to solve this problem.
Okay, got it. Let me find the structures first.
Sure, no worries. Feel free to show me when you're done.
I found 4 carbon chain structures. Is that correct?
Close, but not quite. There are 4 structures, but you've made a small mistake in the 3rd structure. Can you check your work again?
I can't actually find the mistake. Can you show it to me?
For sure. You added an extra hydrogen bond to the 2nd carbon atom. I'm circling it now.
Oh, okay. Good catch. That's actually really helpful. Thank you. So I think this is where the chiral center is. Can you confirm?
Yes, here is the chiral center. Well done.
Remember the optically active isomer problem we were working on? Can you show me what the 2 chiral molecules actually look like?
Sure. Have a look at the molecular structure. I've created the molecular structures of the 2 optically active isomers, also known as enantiomers of 2-bromobutane.
Thanks for all your help, Astrid.
The important lesson towards the end is to remember to thank your AI models. So, yeah, so, what you saw there was this entire end-to-end agentic experience. But what I thought would be useful, so although this seems like a really nice, seamless experience, what I thought would be useful is to deconstruct what are the different parts of this agentic system, right? Now the first component of it is that the model that we use is natively multimodal. So it processes audio and video feeds together. The second thing there is that it proactively decides, it has access to custom tools and it proactively decides which one of them to use. For instance, it knows that you're on a camera view or on a blackboard, and it determines that, okay, like if there is something, like you're learning like a concept or you want to like see a math equation, for instance, it's not going to be helpful for you to like speak it loud or like say it via audio, but rather you would like prefer to have it written down and shown it to you on a blackboard. So it agentically toggles the UI to switch between both these blackboard and camera views. And what's also interesting is that we have this, the model actually creates these gestures on the fly. So if you notice the shapes of the gestures, they're not fixed and they always change based on the context. So like, let's say, one of the example is like the underlining example. If the text was maybe like on one side of the page, it will only underline on that side. So it's not like hard coded and said like, this is the line segment you should draw or something like that. So so the interesting part here is that it also can create this custom gestures, and it again decides between what gestures are most helpful for learning. So it makes these decisions on the fly. Another thing that if you notice that is happening across the 3 different scenes is that the model is actually remembering what the user was, like where the user left them, and is personalizing their interactions based on the past interactions. So when it created this diagram, it knew the problem that the student was solving was on 2-bromobutane and it generated the diagram for that particular compound and not for some random chiral molecules or something like that, right? It also opens up this new, new experience that we call as visual learning, which is we kind of found that students and love to learn via visuals, and having this kind of like experience integrated into one system is something that students really love, rather than having to do this individually. And there's some amount of pedagogical and reasoning that is being built into it. So things that it has to do is identifying mistakes. So most of these problems are complex. Even sometimes a skilled human, if you ask the person to kind of correct the work, is not able to identify the mistake. So, and this has to be done in the multimodal space. And the output sequence is also like a multimodal set of actions because you're using gestures and stuff, right? So it has this reasoning that is being built into it. So if you combine all these capabilities together, you get something like the video that you saw in the past. And these are very early stages. I'm not saying like we have solved learning. There's a lot of things for us to work on, a lot of quality factors to consider, and a lot of hill climbing that we are doing on our different capabilities. But what we've noticed is that there are a lot of applications of using these kind of AI assistants in just education. And I'm just taking the example of education here, but you could think of any particular niche domain that you're working on. One of the key things that the AI agents can facilitate is personalized learning. So you can have you can learn at any point of time. You can learn at your own pace. You can learn with your own style, and the model will also have over time know what your knowledge gaps are, and have this capacity to truly understand you and assist you in ways that doesn't over assume something or about you, right? Then there are other applications that you can build, like for instance, like teaching assistants that teachers could have access to. You could have like simple tools for auto grading student work, curating content, administering quizzes for each individual student based on their specific learning styles. You could have AI agents that create like gamified interactive learning experiences. And there's this other idea that we have been thinking a lot about in DeepMind is we'll definitely reach a future where everyone is going to have their own personalized AI assistant with them. And when these new generation of students come to classrooms, they'll bring with them their own personalized AI assistants. So there might be, it sounds a little dystopian, but there might be this situation where you would have, let's say, your student agents talking to your teacher's agent, and the teacher agent probing these different student agents, asking them if the student did their work or not, if they did it correctly, if they cheated, and stuff like that, right? But yeah, you never know. This could be the future, but we are thinking a little bit about it. So now I'll come to what we do, like how we enable these kind of experiences. So the co-project that we worked on in Google is called as LearnLM. And what is LearnLM is basically, so LearnLM is basically a family of like foundation models that we have deployed and served via Google's many surfaces. Like you have the Learning Code Gem in Gemini app, which is powered by LearnLM. You have Ask YouTube, and people ask me where exactly did you find this? It's actually only on the premium version. So, and then there is search, where there's the homework helper and stuff. But these are the different places in Google itself. We have found like avenues to deploy and test these models for like learning. And this is backed by a lot of research that we do. So we really, we're not trying to solve like an abstract problem. We really want to understand what the students want, how tutors evaluate students, what it means to be a good pedagogical tutor. We don't want to like assume, make a lot of assumptions about what is the best for the student, because we think that is a little dangerous. So we have all these papers, and the most recent paper was on evaluating Gemini in an arena of learning, where we released some more evaluations that compared Gemini with all the frontier models and showed like how our research is actually powering to improve, like to really get like significant impact in terms of improving performance of Gemini in this. And these are like real photos of members of our team working with students, trying to understand their needs, goals, and perspectives. And I think this is important. Like as startup founders, future startup founders, one of the things that you have to really master, I feel, is understanding your user base really well. Because if you don't do that, and if you do not focus on that, you're not going to solve a problem effectively, right? So you might solve something that people don't need. So this is something that you have to do. And an example of us doing that is through creating these workshops, asking students to come here, teachers to come here, give us feedback and stuff. But again, there's a lot of things that we can still do, and I think I'm not saying like this is the only way to collect feedback, but this is just a motivation of like how you can start thinking about users. And based on this kind of interactions that we have had with people, we've kind of like come up with some learning science principles that we think abstract out ways in which people learn. And these are learning science principles that we actually use while developing our models. So we want the models to inspire active learning. We want the models to make the learner work to acquire certain knowledge. If something comes free, it's not appreciated a lot of times, right? If you give away the answers too fast, it's not going to help the student in the long run. But if you actually quiz the student, you actually probe their understanding, make them work for the answer, that is actually a more effective strategy. Managing cognitive load is something that comes up frequently. Like one of the things that we have seen with all these models, like including ChatGPT, Claude, or Gemini, is that you ask it something and it throws at you like this wall of text containing almost all the information that you need about the problem. But this is not the way that you want to learn a concept, but rather you want to like take it in parts. You want to like learn it in like a structured manner, start from the basics, and then dive deeper and deeper into the concepts. You also want to deepen metacognition. Like you want to give opportunities to learners to kind of reflect on their progress. You want to invoke things that they like. For instance, a simple example of this is like if you made a mistake in the past while answering a quiz, and like let's say you're now in a new lesson and stuff like that. You can try to probe the student's understanding of the previous concept by asking the question again and just like nudging the student, hey, do you remember how to solve this or something like that? Now, this is one way in which you can help the learners themselves reflect on their progress. The other aspect which we think visual learning, for instance, is very helpful is in stimulating curiosity. So one thing that we have seen is like there are a lot of physics concepts, for instance, like the Coriolis force, for instance, that when we learned about it, we really just read the theory, but we never could visualize or interact with what would happen, or even when we were solving some questions, let's say on pendulums and stuff like that, we know how the formulas function, we know how the time period of a pendulum, let's say, changes with the length, but there wasn't this paradigm where you could actually create like an interactive web app, for instance, and allow the student to kind of vary the length, see how the pendulum is swinging or something like that. So this is something that I think these are some small things that we have found that actually encourages curiosity. Like if you try to give users something to interact with, something more visual, it kind of invokes this curiosity. And adapting to the learner is also something that is also super important. It's not always that a learner wants to learn in like some pedagogical manner. It's probably going to get irritated if at every point of time we say like these are the steps. I'm not going to give you the answer. These are the steps, and you have to like really learn to adapt. Like there should be at some points where you break through from that behavior of not giving away the answer and then give this answer to the students. And these are really hard problems. We're not saying that we've kind of like we have found a perfect solution to this. We're just saying that these are principles we have identified and we are actively working to find good solutions for. What we do is an important part of all the studies that we do with these models is that our evaluations, right? And we do different sorts of evaluations to tell us the progress that we are making. The most quickest form of evaluation that I think most of you guys are familiar with here are model-based auto-evals. So what this means is that you have like other large language models evaluating the outputs of the model of your base model and telling you which aspects of the base model are good, which aspects are bad. We also run human evals, and these are super important because a lot of times what we observe is that the auto evals are not super indicative of like human values or human alignment. So human preferences are always going to be different. So we run a lot of like preference-based comparisons and human evals. And we're trying to run these efficacy studies in partnership with universities like Arizona State University, where we're trying to get our tutors into the classrooms, allow students to interact with them over the course of a semester, and then trying to do like some randomized control trials where we have like a certain population of students that have access to the tutors, certain which do not, measure the progress. Again, it's hard because there are a lot of other factors that come into play, and it's not just learning in the classroom that impacts, like let's say we can actually make some meaningful claims and say like, hey, this is what we did, this is how we measured it, and this is what we are observing. But we're not trying to say like, we're not trying to imply causality or saying like, this is why it happened. Now I think this is a slide which is a little controversial for me to talk to because of all the confidentiality agreements, but what I try to do is abstract some of the knowledge out for people that might be interested in like training LLMs and like building customized LLMs. So if you think about the training process in, I guess, most big tech, it's generally done in 3 stages. So you have this pre-training stage where you throw this massive multimodal corpus of information into the model, just make the model understand and build its world knowledge. You have the next phase, which is the mid-training phase, where what you do is you actually drop the learning rates in pre-training, and then you focus on certain aspects which are important in pre-training, like reasoning, for instance. So you take like reasoning data sets, you take like coding data sets, and you only train on those kinds of capabilities. So this is what we call as mid-training. And what this does is that through pre-training, we see that, okay, there are some emergent behaviors. Now, if you few shot the model, it can reason a little. Why not amplify this behavior a little more before we start doing post-training? And that's what happens in the mid-training phase. And the last phase is the post-training phase. And post-training phase is where we really want the models to do well on the and accurately perform like end-to-end tasks. So even after mid-training, you won't have an agent that if you throw in complex instruction at it, will be able to follow it or something. So you need like some sort of like instruction tuning and stuff like that. So in terms of post-training, the key techniques that are used is, one of them is instruction tuning, a very old technique but very effective. But it's very important to teach the initial policy to the models through instruction tuning. And one of the paradigm shifts that we have seen in the last year or so is that RL just works. So we're dropping a lot of the initial instruction tuning phase and just betting on RL. One of the good things about RL is that in the case of instruction tuning or like supervised fine tuning, what's happening is that you're giving the model like an input, and you're saying that this is the perfect output for this particular input. But what you don't take into consideration is that when the next generation of models develop, they might produce a better output than what you already have. And therefore, your data that is that you're using for instruction tuning already becomes stale when a new model comes out, right? So that's the reason why I think all the big AI labs are moving away from this instruction supervised fine-tuning, trying to minimize the amount of supervised fine-tuning you do, because you don't want to tell the model that one set of outputs is a perfect set of outputs for a particular task. You want the outputs to evolve. And reinforcement learning actually helps a lot with that. Because in the case of reinforcement learning, all you have is the inputs, and all you're evaluating is the model's performance on that particular input. So even if the policy evolves and starts producing better outputs, all you need to change is your reward functions. Like, can you create a better reward function that more holistically evaluates the output? And if you can improve your reward functions, you can automatically improve the model quality by a lot, right? So that's the reason, that's the intuition behind betting on reinforcement learning, and that's the strategy that most people are looking to right now. And this also opens up an opportunity to a lot of data startups here. So one of the easy things that you can do is that create a lot of prompts for RL and sell it to big tech companies. They'll buy it for a lot of money. They really need this kind of data. But some peculiar observations that I've made over the past few, I would say like past few months of training models is nowadays we are using a lot more, especially for agentic capabilities, is that there's been a lot of emphasis on synthetic data. And a part of the reason why this is there is because it scales easily. Like you can use your current best model to produce the data for the next possible model, and you can use the models in your RL loop as well in a lot of cases, and that has basically kind of led to a lot of synthetic data being used for RL. We have also been starting to see optimization across like very long trajectories. So previously, the optimizations we used to do around prompts that was super like small and the outputs that were like super small as well. But like now we are seeing that, okay, the real gains are coming from increasing the size of the input and the output space in RL. So the challenge, however, is how do you evaluate the RL outputs? Right now, one of the common themes that people do is that they allow models to think and they just throw out the entire thought trace and they just evaluate like the final response after the thinking is done, because it's really difficult to evaluate like very long outputs. And again, this is an interesting research question that is open to be solved by you guys here. But yeah, these were the peculiar observations that I have. And we did a lot of these, we used a lot of this, we contributed to different stages in Gemini. And we took a lot of our research that we had, we built a foundation model, we showed that it was better than Gemini, and then we upstreamed a lot of the training data into Gemini, and we holistically try to improve Gemini for learning. So one of the things that if you see in our most latest paper that we showed is that we used an LMSIS style comparison to measure Gemini on the same pedagogical principles that we designed against every other model. And these were independent human raters that we hired. This is not us doing the evaluations ourselves. And one thing that we see is that focusing really on education, collecting targeted data for education, and really nailing that space is actually allowing Gemini 2.5 Pro to kind of exceed the capabilities of a lot of the other foundation models that you have. And then you see the same in terms of educator preferences. Like we had real tutors who had, who were well qualified in their particular subjects, also rate and give preferences. And again, we see Gemini winning in terms of ELO ratings on these tasks. So one thing that I also would like to put out here is that as part of the LearnLM effort and the overall learning effort at Google, we are looking to partner with a lot of startups. We're already partnering with quite a few. So if you're an edtech startup, you can always register. There's a link in the LearnLM app, or you can reach out to any of us, and we'll get you in touch with people. So what we want to do is we want you to use these models for your customized educational journeys and tell us what exactly are your pain points, what exactly are we missing. And then we want to be the people that can help you fix these problems and allow you to kind of build your own models around this. Now, very briefly, if I were to give you a blueprint on how to build an AI agent like the Astra Tutor. So what are the different steps in coming to that? Is the first and the most important step, in my opinion, is going to be to understanding your user. As I mentioned many times in this presentation, if you don't know what the user wants, you're not going to solve the problem correctly. The agentic era also requires sometimes custom tools. Like in our case, we had to build like this UI for a Blackboard and other kinds of tools. It also requires you to build like some sort of an orchestration infrastructure. Evaluations is what I've highlighted the most in this slide. And I think this is super important. So it's really cool to build an agent that you can show like a few, 10 demos that work really well. But then you don't end up capturing the tail end of losses if you just do that. So it's easy to kind of create like flashy demos, but one of the things that I guess you need to succeed is that this particular agentic experience works seamlessly across many different scenarios and not just the 10 demos that you created. And therefore, for this, you need to develop like robust evaluations. And we have like different kinds of evaluations. For instance, we have model-based evaluations, which evaluate like core reasoning, educational capabilities of models. We have function calling evaluations that evaluate tools. Some examples of this is like if you see the Gorilla open functions, I think V2 or something, is an example of a function calling evaluation where people are actually trying out giving custom tools to agents and seeing the responses and stuff like that. And another thing that we also build as part of our development process is agentic evaluations. So we basically use the surface on which, like for instance, like in the case of Astra, it was a mobile surface. So we actually collected a lot of traces from the camera feed, from this different end user experiences that people had. And we created a lot of evals just based on this, so as to evaluate at different points in the trajectory, whenever we create like a new model or use like a new prompt for the models, whether the same trajectories are being met, whether we are exceeding or not. And these I think are also super important, right? And there are many ways to build it. Each of them kind of depend specifically to your applications. In our case, a lot of them are video-based, audio-based, have like certain tools to be called at certain points of time, and we chunk the videos and we evaluate it at those points of time. And then the first thing is, before you dive into like taking open source, like let's say you are building creating a startup, don't just take an open source model and think about fine tuning it right away. Try to, first find the limits of prompting. Try to find how much you can get out of the model as is without trying to build like very specific knowledge into the models. A part of that is because, as I mentioned, like models tend to, in each stage of training, they tend to become less general from the original pre-training stage. So part of the alignment process is then basically trying to focus the model on the most useful information. So what happens in this case is that if your data set for some reason doesn't encompass like all the possible use cases that your agent or product will be used in, it's probably going to hurt performance and stuff, right? So experiment with prompting as much as possible. Try to get it to work. Try to see where the losses are, and then once you find the losses, that is when you decide whether you want to do model fine tuning or not. So if you think that your task is very niche and the models don't have any knowledge of that particular task, only then you should look forward to doing like model-based fine-tunings. And this is true for like certain cases, like legal and other finance domains where you have like very custom data, you want like very specific tasks. So in these cases, you would have to do some amount of fine-tuning to get the performance you need. And in the end, what you want to do is you want to iterate on this experience. So you want to really solve for that end user experience. You want to really make it as seamless as possible. So keep gathering user feedback. Whenever you build a new agent, you have like this new model. Even if it's not like running big studies, you can actually ask 10 of your friends to kind of come and play with this agent and tell you what is wrong with it. And without telling them exactly, giving them as minimal instructions as possible and asking them to explore the frontier of the agents. I think that works really well. So this is something that we also do. Every time we have like a new agent, we don't tell people what went into or what's the new feature in this agent. We just tell people to play with it and discover the new feature themselves. And we consider it a win if users actually report back the right feature that we built into the model. Because that means that this was found through discovery and not by instruction, and that's actually a good experience to build for. So with this, I would like to come to the final portion of my talk of some tips that I think will help you win in the agentic era. So one of the things that we are seeing that are all the agents that are succeeding nowadays are specialized high utility agents. So finding a problem that is really niche and solving that problem really well and going deep into that vertical is a winning strategy in the present times, right? Agent tooling and workflow control is also important. So whenever you're building tools, infrastructure, orchestrators, make sure that they are in a setup that allows evolution of agents as well. Build them in a modular manner so that you can kind of remove certain components without affecting your entire stack. So don't over-index on a particular type of setup or a particular type of capability. Know that agents will advance and your systems must adapt to it. So build infrastructure that scales with the advancing capabilities. Build trust and confidence. I think that is super important. So whenever you're building agents, always try to have opportunities for users to intervene in the decision-making process, or like as much as possible, try to make the decision-making process transparent. That is something that is going to build trust in a lot of your user base. Tell users how you arrived at a particular decision. It's not going to you're not going to lose your competitive edge. If at all, what you're going to gain is a lot of user trust in this decision. And if users have visibility into this process, then they can also probably intervene and guide the agents whenever the agents are going wrong. And that kind of increases adoption and confidence in your apps. Now, optimizing for speed, cost, latency. I think somebody spoke of Novita here about a startup that does this. I think this is something that you should always look forward to doing. 3P APIs are expensive. Whenever possible, try to use basic techniques that already exist to reduce your cost. Caching, retrieval, things that don't require you to generate all the tokens from the models every time a query comes to you is something that you can innovate on, and that will actually dramatically reduce the cost when you scale your application. And in terms of integration, I think one of the best places to make your agent like super popular is to get them in areas where you already have like users, and user base already exists. Like make intuitive interfaces into your products. This could be through browsers, this could be through messaging apps. Allow all these different entry points into your applications. And having this kind of integration actually will scale your user base faster than kind of creating individual products and doing like a bunch of marketing and trying to get users to like look at that product, because that is really difficult and it's very rare that happens. So integration and showing people integration really helps in this case with whatever is existing. Now what you can expect is coming, and this is important because when you're building, don't build in an overly conservative manner. Know that faster inference is coming. Agents are going to be more intelligent. Token costs are reducing. So if you're developing like for niche use cases, you need a lot of tokens, for instance, to solve that particular use case. Know that it's going to be cheaper over time. You're going to get increased intelligence, so the agents are going to become better. Native multimodality, it's here, but maybe it's not all like fully accessible, but it's coming very, very soon. Very soon you'll have a lot of these companies just giving you agents that can process audio, video, everything together at once. Context lengths are going to get longer. People have started working on memory inside these LLMs that involves like innovations in architectures. So know that memory is also coming in some form or the other. So if you're making some startup decisions and you have some ambitious ideas, remember that these are the things that are coming and these are the things that you can expect to build on. So make sure that you're building an idea that takes these into consideration. And beyond the horizon, what you have is, I think, in the longer term, we will very soon have universal AI assistants that are capable of acting across different domains, different tasks, different modalities. Embodied AI agents, this is, I think, a dream of many people. On the right here, you see IG-11, and this is very interesting because there's this clip in The Mandalorian where IG-11 is actually an assassin robot, but it reprograms itself and it learns everything from scratch. You should watch it. It's very inspiring on how robots can teach themselves to learn everything from scratch. Continual learning architecture is something that we haven't seen now, but I think is going to happen, is models that can update their own weights based on the feedback that you provide, which doesn't happen now. Right now, you have to like do this whole process of like retraining models. But this might happen in the future. And unified agentic memory that will enable like things like lifelong personalization, that's know almost everything that you put and be able to use that memory effectively. So with that, one last slide. When you're building anything, just make sure that you're building safely and responsibly. Giving users, like respecting their privacy, data ownership is like super important. Don't chase profit, chase like user trust. That is something that that is going to help you win. Implement strong guardrails. Like you're going to get, whenever you build a new system, you're going to have malicious actors that are going to try to game your system in ways that you would never imagine. An example of this was when Asta was announced at I/O. We had a particular user that was bombarding the agent with kind of a very, it was bombarding the agent like in a kind of a DDoS kind of type of attack, and we had to we had guardrails in place to ensure that that doesn't happen, and therefore we were able to catch and kind of remove that user from the system. But then there are other things that you also need to consider, right? Fairness and bias, and this is kind of like amplifying with all the black box nature of the LLMs. You don't know, you have less and less visibility into the decision making process. So one thing that is always nice to do is whenever you build these end-to-end workflows, try to audit them, try to make sure that the decisions that the agents are taking are not influenced by irrelevant features, attributes, and always try to build agents that align with human values. Like try to build towards a net positive gain in the world. There's a lot more to get from that. So with that, happy hacking. Thank you, everybody.
How is everyone feeling? Is everyone tired? It's only 12:38. Y'all have to stay up tonight. Come on now. Okay, so we'll just quickly go over logistics and then we'll go over all of the prizes that you can enter. So sponsors, speakers, judges, and organizers will be wearing a black lanyard with a badge. So you can ask us any questions and we'll be taking pictures, live streaming the event and videos. And then there is the Wi-Fi information. It's also in the hacker package. And then in terms of the house rules, do not enter private rooms. We already put labels on them, and only take food from the main island. Do not take anything from the fridge and cabinets. Clean up after yourself. Do not touch anything in that house that's not yours. And there are people living in the house, so please respect the space. If you are allergic to cats, please let us know because there is a cat here. And project submission. You can only enter your project into one track, but you can enter as many sponsored challenges as possible. The deadline to submit is Saturday, May 24th, 2025 at 4 p.m. PST, no exceptions. And we have instructions on the hacker package as well. You must record a 2 to 3 minute demo video that covers the following information and include links to your repository. We will be judging based on innovation, use of AI, originality, and design, and feel free to ask us any questions about that. And then communication, if you haven't already, please join the Discord. We have a bunch of channels where you can ask us questions and get resources. And then now for the prizes. So sponsor prizes, we have Bolt, best use of Bolt. So open to anything from data visualization interfaces to interactive web apps, and that is $1,000 in cash shared amongst your team. For Dalus, AI-powered systems engineering, $300 Amazon gift card. Explore how AI can enhance hardware development workflows and systems engineering processes, anywhere from systems requirement definitions to design, analysis, verification, manufacturing, and testing of large complex systems such as aircraft, robots, satellites, rockets. That's a whole mouthful, but yeah, super exciting. And then there's Leaping AI, build a voice AI agent with Leaping AI YC Winter 25. And so the prize is dinner with Leaping AI team in SF, one-on-one coaching session on how to get into YC, and a referral when you apply. I'll honestly skip over the descriptions because you can find them in this presentation. Orchids is having the best hackathon project website for $350 in cash. Trae is hosting the Trae AI Coding Challenge, so you should use Trae to complete your development, create and use the Trae agent to work with you, and share a screenshot tag Trae's Twitter with hashtag Agenthack, and then the first prize is a $300 gift card, second $200, and third is $100. And now for the prizes, we have the Agentic Systems and Workflow Automation, and all of the prizes are the same for first, second, and third. $250 cash and $150 worth of Mistral credits for first. Second is $150 cash, $100 worth of Mistral credits, and third is $100 cash and $50 worth of Mistral credits. So the first track is Agentic Systems and Workflow Automation. Second is Interfaces for Human AI Collaboration. Third is Personalization and Memory. And fourth is AI Safety and Control Frameworks. And then the bonus prize, Dex is hosting a Best Dex Browser Agent. First is $200 Fast Track Interview and YC Ask Us Anything. Second is $150 and Fast Track Interview. And third is $100. So you should use the Dex MCP template to build a browser native AI agent that knows how to use specific websites and run and use your agent inside the Dex Chrome extension. The grand prizes, so third place is $500 cash, $800 Claude credits, $600 Vercel credits, and pair VC office hours with partner Khalil Fuller. Second place is $750 cash, $1,200 worth of Claude credits, and the same for Vercel and Pair VC. And the grand prize is $1,000 cash from PVP, $2,000 Claude credits, $600 Vercel credits, and Pair VC office hours with partner Khalil Fuller. So thank you and good luck, everyone. Enjoy hacking. And then lunch will be served on the kitchen island. So we'll get that out shortly for everyone. And feel free to come around the house. Do not go upstairs, please, but you are free to explore downstairs. Thank you.
Let's first go there.
Yeah, you can use the skin camera. The camera. Oh, okay. If you good luck with your head. Thank you. Oh, wait. Oh, okay. I'm John. No, I didn't. Oh, are you doing that? Oh, hi. Yeah, I'm just myself. I think I'm gonna meet another guy who's gonna be in here like early afternoon. So yeah, that's so. If you don't mind myself, okay, I can. Yeah, let's do this. Yeah. Yeah, so I've been like 6-year work experience. I've been working as a full stack engineer for 6 years. Lately, just like everyone else, like building the AI agent. I have my own startup. I built a true AI agent where I was able to sell and then business go well, but didn't work out with co-founders, so kind of like we parted way. So right now, I'm just trying to participate in Hackathon, try to catch up. When you do the startup, like you have to head down, just focus on building. But I didn't really have much time to catch up everything, you know, and AI is like moving crazy. crazy, so fast. Right? So yeah, that's what I'm looking for. Try to learn new things and try different projects and meet people. So what about you?
So about me, I have like 2 years of experience back in India.
Oh, okay.
Here I'm working as a teaching assistant for research with principal language model.
Okay.
So we are working on research on emergency medicine. We are using like one of the presentations like we are using multiple agents to like orchestration and give a single output to, for example, one state. So for our use case, it's like emergency medicine. I'm doing
What is that?
emergency medicine.
Okay.
So it's like we are using multiple AI models to like reduce the which are like using the patient having on by the symptoms of the patient is.
Oh, okay.
Okay,
Okay, sure.
like when in emergency medicine, we as soon as the patient comes, it's like a secondary.
Oh, I see.
That's what I'm working on. Other than that, I want to make a couple of hackathons. Two hackathons are even like one year hackathon back in November last year. So I was participating in that. It was a data set. And that I also participated in hackathon where we project known as Novita. It was like we didn't target any prizes or anything like that. But we made a product by ourselves.
Oh, that's cool. That's cool. Yeah, I've been to other hackathons building some kind of like we try to build some device where they personalize the system. Like we're having different all type of different hardware where you can just communicate with your phone and have a different interface. This is like a fully conversational AI in the system. So I've been to a few hackathons. Like I didn't go a lot yet. So. Yeah, that's a good.
I've been to like a few hackathons, but I have never won, so I have planned to win.
Yeah. Me too. So I don't know. Do you have any idea like what are you interested in?
I think we should have a good idea. Focus on particular tracks. One of the hackathons that I there are a couple of hackathons that I want
Oh, I see.
How you guys feeling? Pretty good. Most of my emails online, so it's just so I feel a bit lost right now.
Yeah, I think we just met and then try to see, if there's a team or And then you already have a team, right?
Where do you guys come from?
I'm originally come from South Korea, but I'm living in Brazil right now, but I'm visiting SF. It's a bit of the mix.
The past 4 months I was in South Korea actually. I was there because of South Korea abroad.
Okay.
Yeah.
That's nice. Which university did you went to?
I go to a college in California. It's called Novita.
Okay. Yeah, I heard about it. Oh, you have a campus there, right? Oh yeah, shit. That's a pretty crazy college.
Sorry, it's called Minerva. Essentially, it operates on like a global rotation model, so every semester we move to a different country, but it's based in the US, specifically San Francisco. So it's like, we're all over the place, but we come back to SF every summer. Yeah, it's pretty nice, yeah. How did you hear about it?
I have a sister. I mean, I heard at some point. I have a lot of interest in education, so. But I have a sister-in-law that was about to go to school, and then I heard about the school, and then I was like, hey, I tried to convince her, and then she got interested, but at the end she just want to go to regular university. She landed to the UT Austin, but yeah, I heard that the university is pretty amazing.
What are you planning to build in the hackathon?
Yeah, that's what we're talking about right now. What about you? What are you building?
We're still brainstorming. Yeah, I think we'll like streamline based on the prizes rather than what we're actually doing.
Same idea.
Yeah. So I think that's the goal. So we'll see. I'll leave you guys to whatever you brainstorm.
Oh, okay. Yeah, good to chat.
Yeah,
do you have a LinkedIn?
Yeah,
Let's
sure.
Let's connect. Yeah.
Wait, so what prompted you to come to
My wife from Brazil. And we met in college in the States. Yeah, right.
By the way, if you need to use the bathroom, there's another bathroom on the bottom floor.
Okay, can I get